Okay, so this is notes 1-4. So now we're going to talk about absolute value. Now to define an absolute value, they have a really good definition right here. So the absolute value is the distance between 0 and that number. So for example, if I ask you what is the absolute value of -2, really what I'm asking you is what is the distance on the number line between 0 and -2. Well, the distance between here and here is actually 2. So in general, anytime you have the absolute value of any number, whether it's positive or negative, the answer is always going to be positive. Okay, so let me do a few exercises, so hopefully that'll make sense. So in this one we're evaluating. So what that means is we're actually going to plug in 2 for x in this case. So we have 2 times 2 minus 8. So really we want to know the absolute value of this, all right? And the absolute value, in case you don't know already, is the symbol for that is this 2 little lines right here. So that's called the absolute value. So this would be 4 minus 8, and we have the absolute value of -4. Now remember that really what I'm asking you, when I ask you what is the absolute value of -4, I'm really asking what is the distance between -4 and 0? And the answer is 4, all right? And perhaps after you understand, you don't have to think that deeply about it. All you have to know is that if you have a negative number inside an absolute value, it'll be positive. Notice that I say a number, all right, not a variable or anything like that. So on number 2, we're doing the same thing. We're going to evaluate. We're going to plug in a -6 for z. So we have 6 plus a -6 minus the absolute value of -7. Now this right here, notice that that's going to be 0, so the absolute value of 0 minus the absolute value of -7. And then the absolute value of 0 is just 0. And remember, the absolute value of -7 is positive 7. But because we're subtracting, alright, so again, this 7 came from here, and this minus is this minus. So the answer is going to be -7. Okay? So that's all we're doing in essence. I'll do one more example here, and I'll show you what the answer is for number 3. So for example, if you want to do number 3 on your own, right, the answer to that one would be 15. And all you have to do is plug in this -4 and that -6 here and here, and then figure out the absolute value and add the 5. Alright, so if you want to do that one on your own and see if you get that same answer, that would be awesome. Alright, so let's go ahead and go to number 5 real quick, and this is the last example I'm going to do on this front page. So on number 5, we're going to plug in 2 for x, 1/2 for y, and we have -6 for z. So the absolute value of 2 is just 2, the absolute value of 1/2 is just 1/2, and the absolute value of 6 is just, the absolute value of -6 is just 6. Alright, so all of this inside became positive. However, because I'm subtracting each absolute value, this is what those minuses are doing right there. Okay, so now I'm going to have to add these. Now, if I don't have a calculator, then I'm going to have to find a common denominator. And to do that, if you remember, I can put this over 1 if that makes it easier for you to look at. And I have to find a common denominator. To do that, I would have to multiply this bottom, the denominator, by 2, and if I do it to the bottom, I have to do it to the top. And then the same idea with this side. Right, notice that this will give me 4 over 2 minus 1/2 minus 12 over 2. Alright, which would be the same thing as 4 minus 1 minus 12 all over my common denominator. And that would give me, let's see, 4 minus 1 is 3. 3 minus 12 is -9 over 2. Alright, so that's the answer to that. Okay, and I'm going to go ahead and give you the answers for 4 and 6 in case you want to try that on your own. I got a -1 for number 4. Okay, and I also got an 11 for number 6. So try those out if you like and see if you can get those two answers. Alright, so now I'm going to go ahead and move on to the back. Now on the back, we're actually going to talk about how to solve absolute value equations. All right, and it's something that you probably haven't done in the past, but it's actually simple. It's just more work. So here's a case. Basically, anytime you have something like this, you have to solve it without the absolute value. Notice like that. But you're also going to have a second case where you have exactly the same thing as you do here, but you're going to have a negative 17 here instead of a positive 17. And you have to solve both of them, and you're going to get two answers. And then on top of that, you're going to have to check both answers to make sure they're correct. And I'll explain why you have to check in just a second. So let's just go ahead and move on to number one. Alright, so number one, remember what I told you, what you're going to have to do is you're going to basically, to solve this, you're going to basically ignore the absolute value, and you're going to solve for this equation. Alright, so let's just quickly solve for that. We're going to subtract 15 from each side, and that would get x is equal to positive 22. Alright, now that's case one. So you actually have to do another equation where you have x plus 15. Notice that the inside of the absolute value did not change, but now you're going to set that equal to negative 37. Alright, and now you're going to have to solve for that. So if I subtract in like manner, I would get x is equal to negative 52. Okay? So I have two answers. So now you're going to have to check. And to check is actually very simple. Although I will not be checking every one of these on the notes, you should check every one of these. Okay? So to check, all you have to do is plug in a 22 inside this absolute value. And then the question is this equal to 37? Alright, notice that this would be the absolute value of 37. Is that equal to 37? The answer is yes, it is. Alright, so that one is actually true. So this is a legitimate answer. Now, on this one right here, x is equal to negative 52, same thing. You would plug that into the absolute value, have negative 52 plus 15. Is that equal to 37? Alright, so it turns out that if you add those two together, a positive negative 52 plus a 15, a negative 52 plus a 15 will give you negative 37, the absolute value of that. And we know that the absolute value of negative 37 is positive 37. So that is also going to check out. Okay? Now, if you're wondering why do I have to check that? It doesn't make sense. Or why do I get two answers? Remember that what is really going on is, I'm going to show you the calculator so hopefully it'll bring you more understanding. Right, if you put this in y equals, right? Notice that I put y1 as x plus 15, the absolute value, and y is equal to 2 is equal to 37. Y of sub 2 is equal to 37. Now notice that this right here, y is equal to 37, is going to be a horizontal line. Okay? And now if you didn't know that, the absolute value, and you'll see it on the graph, looks like a V. Alright, so that's the absolute value right there. And then there's 37 right there in this red line. So what I'm really asking you is, when is this absolute value equal to 37? This line is the 37. So the answer to those happens to be the intersection between the red line and the absolute value. So this is actually negative 52 all the way over here. This is when this happens, and this is actually 22. So that's what you have to check. Alright, you have two answers for each one of these. Potentially. Sometimes you only have one. Alright, so let's go ahead and look at number 2. Alright, so number 2, on all of these, before you do the two cases, you must isolate the absolute value. Alright, so what I mean by that is you must get this absolute value by itself, meaning that 5 right there has got to go. Alright, so we're going to do it very similar to what we did on a linear function. We're going to add this 5. I want to get rid of that 5, so to get rid of it, I have to add it. And then that would give me the absolute value of t minus 4 is equal to positive 5. Okay? And then now I can go ahead and do the two cases. I have t minus 4 is equal to 5. That's case 1. In case 2, I have t minus 4 is equal to negative 5. Alright, so remember, I have to have one exactly the same as this one, and one of them would be with a negative. Alright, so now I'm going to solve for t. So t is equal to 9 on this one, and t would be equal to negative 1. Alright, so notice that I'm just adding 4 to each side. Alright, so I have two answers. Now, on this one, if you go ahead and check it, I'm not going to check it myself, but this actually wouldn't be a really bad one. You come back to this original equation and plug that in, and then you would see that that actually does work. Alright, and I'm actually going to, let's just go ahead and do it. So we have the absolute value of 9 minus 4 minus 5. Is that equal to 0? Well, this is the absolute value of 5 minus 5 is equal to 0. And the absolute value of 5 is 5. Minus 5, that's going to be 0. So that works out. So this is a legitimate answer. Alright. And on this one, same idea. I'm going to plug in a negative 1 here. Minus 4 minus 5. Is that equal to 0? Alright, notice that this would be the absolute value of negative 5. Minus 5 is equal to 0. And we know that the absolute value of negative 5, which is the same thing as the distance between 0 and negative 5, well, the absolute value of negative 5 is positive 5. Now if I subtract the 5, that will give me a 0. So this is also a solution. Alright? Okay, so let's go ahead. I'm going to skip to a question. Let's see. Like this one. And let me just stop here. On number 3, I'm going to show you that there is two answers. And by that I mean you can go ahead and pause it here and see on this one. Actually, you know what? Let me go ahead and do this one because that might be confusing for y'all. So on this one, you're going to have two cases. You have, notice that the absolute value is already by itself. That's how I want it, or it's by itself. So now I'm going to have two cases. One that's a positive. That's case 1. And this one, you would have a negative. Or notice I'm writing this negative outside the parentheses. Okay? So again, notice that I have almost exactly the same thing except for I made this one negative. Alright, so now I'm going to have to solve for m on each side. On this one, you would add 2m to each side. And just because I'm running out of space, I'm going to go ahead and, this time went too far. I am going to go ahead and simultaneously I'm going to subtract the 3. So that 3 cancels. I'm going to subtract the 3 from here. So this is going to be 3m is equal to positive 9. Alright, and I'm going to divide each side by 3. Now if you check this, it turns out that this is an answer. So that works out, and you can almost do that in your head, right? If you put a 3 here, that would be the absolute value of 6, which is 6. And if I plug in a 3 here, that would give me a 6. 12 minus 6 is also a 6, so that works. Alright, on this side, before I do anything, I'm going to distribute that negative. So that's going to change the signs on these. And then after that, I'm going to add I'm going to try to put all the m's on one side and all the numbers on the other. Okay, so if I subtract 2m from each side, and if I simultaneously subtract 3 from each side, I would get, let's see, that cancels, negative m is equal to negative 15, which means that m is equal to positive 15. Okay, so I'm actually going to check that just to show you that I'm pretty sure this one's not going to work. So this one right here, I would have the absolute value of 15. Notice that I'm plugging that in back, I'm plugging this answer back into the original. So I got 15 plus 3, absolute value of that. Is that equal to 12 minus 2 times 15? Now this is going to be the absolute value of 18 on this side. Now on this side, this would be negative 30, and that would be 12. So this is going to give me a negative well, let me write it out, 12 minus 30. So this is going to be 18, and this one's going to be negative 18, which I know that's not true. So therefore, this is what we call an extraneous solution. All right, and how that happened, even though I can't see the picture, is that this must intersect only one of the legs of the V. All right, and that does happen from time to time. All right, let's go over number 4, and that'll be where I leave you with it. All right, again, we want to isolate the radical, so we're going to subtract 16 from each side. Oh, excuse me. So we have the absolute value of 5b plus 9 is equal to negative 14. Okay? So now in this case, we're going to have one case where it's 5b plus 9 is equal to negative 14. So that doesn't change. And then we have another case where we have 5b plus 9 is equal to a negative of a negative 14, which is then going to make it a positive. All right. So we're going to subtract the 9. We have 5b is equal to negative 23. And we're going to divide by 5, and this is going to give me negative 23 over 5. And on the other side, I would have 5b plus 9 is equal to positive 14. If I subtract 9, I get 5b is equal to 5. If I divide both sides by 5, I get that b is equal to 1. Now, it turns out that when you plug both of these back in here, both of them do not work. Alright, so I like to bring this back to a picture. So you might be thinking, well, how can that not work? Right? How can that not work? And I'm going to show you what happens here. And I'm going to use the calculator to show you that. Alright, so even though the window is a little bit different, alright, notice that I have the same equation here, 5b plus 9. The absolute value of 5b plus 9 plus 16 is right here, and then we have a 2 here. So really, the question is asking, when is this equation right here, when is this graph going to intersect at 2? Alright, so if I look at the graph, you're going to see very simply that it'll never happen. There's the absolute value, and there is 2 right here. So the problem then becomes that the reason both of the extensions do not work is because that's never going to happen. The v is up here, the 2 is down here. They will never intersect. So this function cannot ever be equal to 2. That's as simple as that. All right, so I hope that helped. I hope the picture helped. Now, I'm going to show you the answer for number 5 in case you want to try that out on your own. Let me just show you the answer for number 6 instead. One answer is A is equal to 11 over 2 negative. This is for number 6. And that works. And we have another answer where we have, let's see, A is equal to 3/2. And then this one actually doesn't work. All right. Now, I do not mean that you shouldn't try it. Well, that one doesn't work. I shouldn't try that side. Try it out. Okay, so try this problem also. And see if you can do it. And if you can't, come see us in the morning and we can help you out with that.